Hello folks, how's it going? This is Avijit here, and welcome to DevOps Challenge Hub. So let's start with today's interview question. And today's interview question is, why do we need a CI/CD? And explain a high-level AWS CI/CD flow. So first we'll discuss why do we need CI/CD. So CI/CD we need for faster delivery because it automates the build, test, and deployment process, and it reduces manual error. So if CI/CD is not there, developer may not check in the code regularly in the repo, and it automatic test won't be executed. And if there is some error, developer won't be notified because someone has to do manual testing. Developer might have checked the code in US time, and maybe the team who is responsible for the testing, they're in India. So there will delayed feedback. And here, feedback will be faster because as soon as the developer checks in, CI/CD pipeline will be triggered. Automated build will be compilation build will be done. If there is a compilation error, immediately developer will come. Because sometimes what happens, some header file is there on the developer machine, and because of that, it's compiling on developer machine, but it's not added in the repo. It's not checked into the committed to the repo. So that's why it's failing. Or some library is missing. Some configuration file is not updated. So developer, when he compiles, it's working fine, but someone else when checked out the code, it's not working. And when developer goes back home and the developer who is working on the other side, maybe in different time zone, he comes in and he finds that there are a lot of issues are there because it's not compiling. So it will delay the whole process. So here what happens in CI/CD, you get immediate feedback because as soon as you check in the code, automatically code will be checked out and compilation build will be done. Automated unit testing will be carried out so that you get a feedback. If there is a failure, developer will get a notification by email or Slack, right? Or Jira ticket will be created. So that's the advantage, faster feedback, better quality, early bug detection. Code is tested with every commit, continuous integration. Manually, it's not possible to test every code. There will be too much effort, right? So that effort also will save time, also time, money, everything will be saving. Problems are caught early in the development, not in the production. Better code quality encourages frequent smaller commits and automated testing. Makes code more modular and easier to read. So as soon as you are making small changes, fixed one bug, you commit it. And automated compilation, build and testing will be done and you will get a quick feedback. Automation and consistency ensure consistent builds and deployment across environment. Eliminates it works on my machine problem because sometimes it happens it's working on developer machine but it's not working on a tester machine or QA's machine or someone else's machine. It improves collaboration. Developer merge their code frequently, encourages better teamwork and reduces integration conflict. Otherwise, like developer made some changes in the API and another person is using that API, he did not make that changes. And when he tries to compile, it will fail because he has not made that changes and build will fail. And immediately there will be feedback that there is some change. So they have to integration conflict, immediately it will be resolved because developer is getting immediate notification. Otherwise, it may happen after 3 4 days and people will forget what kind of commits changes gone into this. Right? And since the changes are done recently, so it will be there in the fresh in the memory. Rapid iteration and feedback. CI/CD enables continuous feedback from stakeholders and users. Quickly roll out features, A/B testing, bug fixes. So if it is a CI/CD is there, continuously it's getting deployed. After continuous integration, it's getting deployed. An user or the manager, if it is a deployed on the test environment, their development environments, and then the manager or stakeholders, they'll be able to provide quick feedback. They'll be able to use the app or use the website and give quick feedback. Cloud and DevOps friendly. CI/CD is core to DevOps practices and cloud native environment. Scales with microservices, containers, and infrastructure as code. So they are the advantages in faster delivery, early bug detection, better code quality, automation and consistency, improved collaboration, rapid iteration and feedback. Next, we'll go discuss about the AWS CI/CD flow. First, we'll take an easy example where there is a web app, a few just website pages, and you are going to deploy on EC2. There is no Docker involved. So it's a straightforward. You just GitHub code is there in the GitHub, and as soon as the developer changes some HTML file or CSS file or JavaScript, there will be push or commit, uh, push the repo, and then it will trigger the code pipeline, which will pull the code from the GitHub. Then there is no build actually because it's a HTML page. It may do some lint or test using, it can do some kind of basic testing. After that, it will directly go to deploy. Code deploys, copies the code to EC2 and executes the script. So code deploy, like EC2 has the agent, so it can talk to the code deploy. And code deploy is going to copy that file into a particular folder or directory. Right? That's the basic flow. Code deploy can do some static code analysis, unit test, Slack email notification, etc. Next one is front end plus backend, and it has to be Dockerized and then EC2 deploy. So you have a front end plus backend, and you'll be Dockerizing it and EC2 deploy. So what will be the flow? Same like you start with the GitHub, and as soon as the developer completes the code, it will be checked out, and then it will be built. Docker images will be built and pushed to ECR or pushed to Docker Hub. So that image is pushed to Docker Hub, and then the deploy, it will maybe pull from the ECR or Docker, and basically it will log into the EC2 instance because it's going to deploy there. So it's log into EC2 instance and then pull that image from there and Docker Compose up. If it is already running, then Docker Compose down, then followed by Docker Compose up. So that's it. This is the flow for this scenario. Next scenario, front-end plus backend, Dockerize, and here instead of EC2, we are going to deploy ECS. So all the steps, initial steps will be same. A GitHub developer will commit the code in GitHub. It will trigger the pipeline. Code will be checked out. Docker image will be built, pushed to either Docker Hub or ECR, right? And then deploy to ECS. Deploy to ECS. ECS cluster is already running. We'll discuss about ECS in the next set of interview questions. But ECS is running container clusters, and then in that ECS, the service update will happen. And then it will update that ECS with the Docker containers, updated images. Then next one is a front-end plus backend Dockerized EKS deploy. So here also process is almost same. GitHub push, then it will trigger the build. Docker image will be created. It will push to ECR or Docker Hub. Then using kubectl command, it will be deployed. And there are some additional things also we can do. And then the last one is a front-end backend. It's a GitOps, Dockerized, and GitOps velocity. So here what's happening, here also we will start with the GitHub application repo. As soon as the developer pushes the code, it will be checked out and Docker image will be built and pushed to ECR or Docker Hub. Then that image tag will be updated in the another repo will be there where this GitOps repo where this Kubernetes manifest file etc. will be there, and then it will be updated. Once that is updated, this deployment will be triggered automatically by Argo CD. So Argo CD and this GitOps will be always in the sync. Argo CD sync updated GitOps repo and deploys to EKS. So deployment will be handled by Argo CD. So these are the different way flow happens, and so GitHub push, pull latest code, source code. Okay, so we have different stages. Source. Once you do the GitHub push, code pipeline will pull the latest code, and then code build will do build app, Dockerize, run test, scan, push. All this activity it will do. Then after that, deployment will happen. Deployment, it can be code deploy, it can be Argo CD, or it can be from command line also can deploy. So you can run some script and it will do the deployment. So deployment can be on to EC2 instance, or ECS cluster, or EKS Kubernetes. And additionally, we can do all these code things in code build, like unit test, static code analysis using ASL lint, SonarQube. Security scan we can do, review for Docker, Jacob, Bandit, Docker signing, infra linting, Kuberlinter, then pre and post deployment test, update Git repos, commit manifest, image tag update to Git repo, Slack email alerts, tagging and versioning. So all these activities can be done in the deploy. So this is the high level flow. So in in the interview question, you can answer pick up one or two flow. You can just explain, and or whatever you have done in your project, you can explain that way. If you have done GitOps Argo CD, you can explain that GitOps Argo CD. If you have done ECS, you can explain that ECS. Or if you are doing simple EC2, you can explain that. Now let's go to the quiz section. In a simple EC2 deployment without Docker, what is the primary role of AWS code deploy? What is the primary role of AWS code deploy? So EC2 deployment, primary role of code deploy is to just to copy that files, copy the code to EC2 and execute deployment script. So that's the primary role. It's a Dockerless without Docker. So primary role will be deploying is just copying that whatever binary or files to EC2 instance and execute some deployment script. So answer is D. Next question is, which of the following is an optional stage in this code pipeline? So we have seen that the first one where HTML files that are getting updated and it's getting deployed to EC2. There's no build, right? There's no build. We don't need to build anything. It's not an application to compile. Like C++ application, C application, we need to compile, right? Or Docker image, we need to build. But HTML, we don't need to build anything. Just to copy the file. So build is this is an optional stage. This is an optional one. Source, we need to definitely the code base we need to pull from source and deploy we need to do. And the next one is in this setup, what command is typically used during the deploy stage to EC2? So when you are deploying to EC2 instance, or what do you do? Like if it's a Dockerized app, means Dockerized setup. So it will be a Dockerized app setup. So in the Dockerized app, when you're in EC2 instance, you will just do Docker compose down. First, you will stop the Docker, then Docker compose. You have to pull the latest Docker image, and then Docker compose up. Scenario front-end, backend, Dockerized, ECS deploy. ECS deploy, what is the deployment method used in this scenario? So ECS deploy, you will be just ECS service update prior task definition. How is the deployment typically triggered in AKS pipeline? AKS pipeline, you can use kubectl apply within the code build. You can using command line also you can trigger it. So here answer will be B. So that's it for today. Hope you like this video. Please like, share, and subscribe to my YouTube channel. And also let me know in your comment how you are finding these videos. And also follow my LinkedIn channel, LinkedIn page, Devops Challenge Hub. I post quiz and contest daily, organize contest, daily contest, and you can participate in that. And follow my WhatsApp channel, Devops Challenge Hub. I post updates regularly. Thank you for watching this video and see you again in the next video.